Okay, so this is page 175, the extension questions. Some pretty good questions to see kind of what our understanding of Lenz's law is. So we're going to go through all 5 of these. I'm doing it from top down so that you can kind of see my hands as I work through it. So the first one, 2 metal rods, A and B, are connected to separate batteries placed near each other, as shown in the diagram. Determine if the rods will attract or repel. So we have 2 rods, and then we have this direction of electron flow. So the electrons are moving this way through that wire. So if I take my hand, okay, so it's going from negative to positive, so there's my thumb. So now I have a straight wire. My thumb is the direction of electron flow, so the direction of the magnetic field is this way around that coil. Then when I go around the other one, so it goes from this side, goes through there, the direction of the magnetic field is the same. It's that direction. Now, when we did kind of this type of question before, we looked at it kind of from the front view. But one way to do it is kind of, so picture these magnetic fields as tiny magnets. So when I have this top one, so the direction is going that way, so it's going to be out from north and into south. So this would be the north pole. I'll write it outside, I guess you can see. This would be the south pole. And it would be the same for this one. This would be the north pole, and this would be the south pole. So if I had 2 magnets like that, I would expect them to attract each other. So I would expect that these 2 wires, these rods, would attract each other when it's turned on. Question number 2, now we have cross-sectional diagram shows the current, assume electron flow carrying wire inside a magnetic field. Each side of the electromagnet requires its own battery to create the electromagnetic poles. Label the polarity of the electromagnets indicate the direction of electron flow, and draw on the battery so that the polarity will cause the wire to move downwards. Okay, so a lot of stuff going on here. The big idea is we want this wire to move down, and it's going to move down because of the magnetic force, so that's my palm. So I want this wire to move down, that's my palm. Now, the direction of the electron flow is out of the page in this wire, so that's my thumb. So palm down, thumb here, means that this external magnetic field, my fingers, need to be going that direction. That's the direction of the magnetic field. Now the magnetic field will be out from north and towards south. So working backwards, this will be the north pole. This will be a south pole, which makes this a north pole, and this a south pole. Now I go to my, I guess it's called the second hand rule for coiled wires. So here's my thumb. That means my fingers are curling over. Electrons are moving this way, which makes this the negative side and this the positive side. In this wire, so here's my thumb, there's the north. Fingers are curling over. So electrons are going that way, which makes this the negative side and that the positive side. And then for question number 3 to 5, we have a lot of stuff. So we have a beam of electrons pass through. We want to identify the polarities. Okay, so there's a lot of stuff going on. This one's exciting. This is everything put together. So we need to start here, okay? So the first idea is we are moving this magnet in, so that's Fa. Now the big idea for Lenz's law, so we start with Lenz's law down here. The big idea is that Fm opposes Fa. So if my applied force is moving this magnet in, I need a magnetic force that opposes that. So if Fa is moving in, that means that this needs to be a north pole because that will repel it, which makes that the south pole. So if we know that then, okay, so then we're going to induce an electron flow here. So here's the north pole, my fingers are curling over this way, so the electrons are moving in that direction. So electron flow is here. This is a complete circuit, so this way it'll be going there. So when I look at this coil then, the electrons are going over. So my fingers curl over. That means this is the north end and this is the south end. I follow this one. So there's my electrons. They're going under. Makes this the north end and this the south end. So then we have, now so we just follow that circuit using our second hand rules, our hand rules for coiled wires to determine the direction of the polarity of those magnets. Then we want to find the direction the electron beam deflects. So now this is kind of the third hand rule. So this electron beam is coming out of the page. That's my thumb. The external magnetic field, again, is to the right. I determined that using those coils. And so my palm now is pushing that down to C. So there will be a magnetic force down. So yeah, 5 questions where we're really just applying kind of all these different rules. So a lot of stuff going on in these questions. They're pretty complex. It really requires us to kind of work backwards. So start from a point and then just using our hand rules logically build in the different parts of that system until we get what the question is asking.